Dear students, in this lecture, we shall learn about a certain type of definite integrals, and it is known as improper integral. As we know that the meaning of improper is something which is unfitting. So we are dealing with something which is not according to the norms, which is not something normal, and this is what we are going to observe mathematically as well as diagrammatically in these definite integrals. Something which is not suitable in economics is undefined or infinity, because the economic variables, they are usually defined, they have certain limits. It can be there in mathematics as well. Even in mathematics, we do not consider infinity as a suitable or a befitting situation. It is something unfitting. So in both of the disciplines, infinity is unwelcome, and how it can occur here in this type of definite integral, there are two possibilities. The first one is in infinite limits. They can appear in integration, either lower or upper limits, or the overall integrand can become undefined. So let us talk about them one by one. I'm choosing the first one for elaboration, and as you can see, I have mentioned two possible examples. And in both of these examples, you can observe one common thing, and that is you can see infinity in them, either in the upper limit or in the lower limit, either with a plus sign or with a negative sign. So the thing is that there will be infinity in either of the limits. So this is what we have done here, and now we are going to see a numerical example of that. The first example here is with this function, which is 1 over x squared. And I can solve that by using the power rule. The answer will be minus 1 over x. Now the limits, they are carried as they were, and afterwards they are introduced into the answer. And the answer is there, which is 1. Now we should try to plot it. And if we plot it, we can see the lower limit is visible, and there is a starting point of the area that we have to measure. As we go ahead towards right, this area gets narrower and narrower, and it's just like meeting the point at x-axis. So we have an answer which is defined, the area is equal to 1. Now there is another possibility. Let us see. This is another example in which the function is 1 over x, integration of which will be natural log of x. The upper and lower limits, they will be retained as they are, and we'll be substituting those limits, and the final answer is there. In this case, the answer is undefined. And if I consider that in the diagram, I'll see that the lower limit, as it was 1, it's plotted, right? But as I go ahead, I start measuring the area which I'm highlighting. You can see it's not meeting the x-axis. The curve is not meeting the x-axis. So it's like an asymptote which is not going to meet the x-axis, due to which छोटे छोटे areas इकट्ठे होते जाएंगे, और जो आंसर है उसकी कोई लिमिट नहीं होगी. It will be undefined. We'll be collecting very, very small areas, and the answer will be of that area that will not be defined, that will be undefined. So this is how we can understand it diagrammatically. It's an improper integral. The other possibility of having an improper integral is that the integrand is infinite. For example, if I have this numerical instance, it's a function and it has a lower and upper limit. You can see यहाँ पर कहीं पे भी आपको infinity नज़र नहीं आ रही. It means कि हमने पहली possibility की बात नहीं की, ये दूसरी की बात की है. अब इसमें जब हम आंसर निकालेंगे, that can become infinite. आपने देखा कि 1 over x की इंटीग्रेशन, that was natural log of x, हमने कैलकुलेट की. लिमिट्स को हमने रिटेन रखा जैसे पहले भी करते आए हैं, और उसके बाद उनकी सब्सटीट्यूशन की अपर और लोअर लिमिट्स की. तो जो जवाब हमारे पास आया वो इन्फिनिटी विद अ नेगेटिव साइन आया. इट मीन्स के देयर वाज नो इन्फिनिटी इन ईदर ऑफ द lower or upper limits. They were 0 and 1. Infinity was not there, but the answer is undefined. So this is the other possibility in which we can get an undefined answer, and we can say that this is an improper integral, which is not making much of the sense, especially in the arena of economic environment. This is how we can have economic the improper integrals. Now the economic examples, they do exist, and we try to make sense of them, and the examples of them are perpetual bond or revenue from an indestructible capital asset. Now, both of these have this thing in common. Their end is not defined, their end is undefined. If we have a piece of land, it is going to last for we don't know how long. So it's undefined. This is where the improper integral can fit in. And if there is a perpetual bond, there is no specific end in our sight of that bond. That is why of that financial instrument, the value, if it is calculated, it's likely to be undefined. So these are a few situations in which improper integral can fit in, but not in the usual environment of the economic models and situations. Thank you.